So let's take a look at an example. Here we have a vector in R3, v equals -1, -3, 2, and we want to find a unit vector that points in the same direction as vector v. So based on the formula that we just derived, we know vector u is going to be 1 over the norm of v times vector v. Okay, so let's start by calculating the norm of v. So the norm of v, the magnitude of v, that's just the square root of the first component squared plus the second component squared plus the third component squared. So that's square root of 1 plus 9 plus 4. So I get 14, square root of 14. And so if I plug that in, then I want 1 divided by the square root of 14 times vector v, which is -1, -3, 2. Okay, so 1 over norm of v, that's the scalar, and then vector v is the vector. So I'm doing scalar vector multiplication. And if I multiply, I get -1 over root 14, -3 over root 14, 2 over root 14. And I know this vector is going to be pointing the same direction as vector v, because all I'm doing is I'm multiplying by a positive scalar. When I do scalar multiplication, if the scalar is positive, the vector points in the same direction. I just change its length. And to double check that I have a unit vector here, so just to be clear, this is my answer. But let's make sure that the answer is actually what we want it to be. We want it to be a unit vector, right? So I can check that by finding the norm of u. Norm of u better be 1, right? This better be a unit vector. So square root of the first component squared plus the second component squared plus the third component squared. So first component squared, I get 1 over 14. Second component squared, I get 9 over 14. And the third component squared, I get 4 over 14. Three fractions have a common denominator, so I could just add their numerators together. 1 plus 9 plus 4 is 14 over the common denominator of 14. 14 over 14 is 1, and the square root of 1 is 1. So yes, u is actually a unit vector. This is actually what we want. It is pointing the same direction as the original vector v, but now it has unit length. It is normalized. It has length 1. And so it allows us to focus on just the direction of vector v without worrying about the magnitude of vector v.